Have you ever wondered if time travel is possible? It sounds like fantasy, but it's real, and astronauts are the proof. Every person who's left Earth has also traveled through time, thanks to the laws of physics. This isn't the time travel of movies. It's a subtle, one-way trip into the future. Science fiction imagines time as a river we can navigate, but reality is even stranger. Astronauts experience time differently than we do on Earth. It's not a theory, it's a measured fact, rooted in Einstein's revolutionary ideas. On Earth, we assume time flows equally for everyone, but that's just our limited perspective. The universe has a flexible view of time, and for astronauts, time itself behaves differently. How? Because space and time are woven together into space-time, a fabric that can be bent and stretched. When astronauts launch, they travel through space-time, changing their relationship with time forever. They return to Earth, having lived just a little less time than we have. Time travel isn't just fiction, it's happening above our heads. Let's find out how. To understand this, we turn to Albert Einstein, who showed us that time is not absolute, it's relative. Time depends on your speed and your position in the universe. The faster you move, the slower your time passes. This is called time dilation. Imagine two people. One stays on Earth, the other travels in a fast spaceship. When they reunite, the traveler's clock is behind. This isn't a trick. Time itself slowed down for the traveler. Gravity also bends time. The stronger the gravity, the slower time moves. On a mountaintop, time ticks a bit faster than at sea level. For astronauts, both effects matter. Their high speed slows their time, while weaker gravity speeds it up. In low Earth orbit, speed wins. Their clocks tick just a fraction of a second slower than ours. This cosmic tug-of-war is happening every day. Astronauts are living proof that time is flexible. Einstein's theories aren't just ideas, they're reality. Time travel is built into the universe, and we can measure it. Time dilation needed proof, and in 1971, physicists Haffel and Keating delivered it. They flew atomic clocks around the world on commercial jets, eastward and westward. A reference clock stayed on the ground. Einstein predicted the eastward clocks would lose time, the westward clocks would gain time. After the flights, the results matched the predictions. The clocks disagreed by billionths of a second. The differences were tiny, but real, recorded by the most precise clocks on Earth. This was the first direct evidence that time isn't constant. Every time you fly, you're a time traveler, by a few nanoseconds. The experiment proved that speed and gravity change time. Time travel isn't just for astronauts, it's for anyone moving fast or changing altitude. Haffel and Keating turned theory into fact. Time is not fixed, and astronauts experience it most dramatically. Now let's go to the International Space Station, orbiting Earth at 17,500 miles per hour. Astronauts aboard the ISS live in a constant state of high-speed motion. Einstein's theory predicts their time passes more slowly than ours. For every 6 months on the ISS, astronauts age about 0.005 seconds less than people on Earth. It's a tiny difference, but it's real and measurable. Scott Kelly, after nearly a year in space, returned 0.001 seconds younger than he would have been on Earth. Mission controllers track these differences daily. The ISS is a living experiment in time dilation. Astronauts are proof that time is not the same for everyone. Their present is a fraction of a second behind ours. As they orbit, they drift into the future faster than anyone on Earth. The ISS is our first step into a world where time is a destination. Astronauts' time travel is tiny because their speeds are far below the speed of light. But if we could approach light speed, time dilation would become extreme. Imagine a mission to Alpha Centauri at 99% light speed. 8 years pass on Earth, but only 1 year for the crew. They'd leap 7 years into the future. The faster you go, the bigger the jump. Gravity can also slow time dramatically, especially near black holes. Near a black hole's event horizon, time nearly stops compared to the rest of the universe. In an hour near a black hole equals 7 years far away. That's real physics. An astronaut orbiting a black hole could return to Earth centuries in the future. Time travel to the future isn't just possible, it's a consequence of the universe's rules. The ultimate one-way trip is written into space-time itself. Extreme speed and gravity are the keys. The future is closer than you think. Time dilation isn't just for astronauts. It's in your pocket. GPS satellites orbit Earth with atomic clocks moving fast and far from gravity. Their speed slows their clocks by 7 microseconds a day. Weaker gravity speeds them up by 45 microseconds. The net effect: GPS clocks run 38 microseconds faster than clocks on Earth. That tiny difference matters a lot. GPS works by measuring the time it takes signals to reach your device. Without correcting for relativity, GPS would be off by miles within minutes. Engineers program Einstein's equations into every GPS satellite. The system constantly adjusts satellite clocks to match Earth time. Without relativity, your navigation app would be useless. Time travel isn't just for science fiction, it's essential for modern life. Einstein's ideas guide us every day. The universe's rules are in your hands. So, are astronauts real time travelers? Absolutely. Every second in orbit, they leap microseconds into our future. The Hafel-Keating experiment proved it. GPS depends on it. Astronauts return to Earth having lived less time than we have. This is time travel as we know it, a one-way journey forward. The closer you get to light speed, the more you trade your own time for a leap into the future. As we explore farther, these effects will grow. Mars missions will mean astronauts return seconds ahead. Interstellar travel could mean years. Future explorers will be pioneers of time, returning to a world that's moved on. So, look up at the night sky. Our first-time travelers are already out there. If you could leap into the future, would you take the chance? The universe offers the ticket. The choice is yours.